Kepler-22b is an extrasolar planet orbiting G-type star Kepler-22. It is located about 600 light-years from Earth in the constellation of Cygnus. It was discovered by NASA's Kepler Space Telescope in 2011 and was the first known transiting planet to orbit within the habitable zone of a Sun-like star. Discovery and observation. The planet's first transit in front of its host star was observed on Kepler's third day of scientific operations, in May 12, 2009. The third transit was detected on December 15, 2010. Additional confirmation data was provided by the Spitzer Space Telescope and ground-based observations. On December 5, 2011, the confirmation of the existence of Kepler-22b was announced. Past transit dates, orbit. The only parameters of the planet's orbit that are currently available are its period, which is about 290 days, and its inclination, which is approximately 90 degrees, so that it transits the disk of its star as seen from Earth. No information is available about the shape of the planet's orbit. Many extrasolar planets are known to move in highly elliptical orbits. It is only known that its average orbital distance is within its host star's habitable zone. If Kepler-22b has a highly elongated orbit, it may well only spend a small fraction of its time within this habitable zone, which would cause extreme temperature differences on the planet and might make it inhospitable. In order to obtain information about the shape of the planet's orbit, other methods of planetary detection, such as the radial velocity method, need to be used. While such methods have been performed on the planet after its discovery, they have not yet detected what the orbital eccentricity of the planet actually is, and have as of March 2012 only set an upper limit on the mass of the planet. Physical characteristics. Kepler-22b's radius is roughly 2.4 times the radius of Earth. Its mass and surface composition remain unknown, with only some very rough estimates established. It is less than 124 Earth masses at the 3 sigma confidence limit, and less than 36 Earth masses at 1 sigma confidence. The adopted model in Kipping et al. Does not reliably detect the mass, though the mass is below 52.8 Earth masses to 95% confidence. Kepler-22b might be an ocean-like world. It might also be comparable to the water-rich planet GJ1214b, although Kepler-22b, unlike GJ1214b, is in the habitable zone. An Earth-like composition is ruled out to at least 1 sigma uncertainty by radial velocity measurements of the system. It is thus likely to have a more volatile rich composition with a liquid or gaseous outer shell. This would make it similar to Kepler-11f, the smallest known gas planet. If it is mostly ocean with a small rocky core, Natalie Batola, one of the scientists on the project, speculated, it's not beyond the realm of possibility that life could exist in such an ocean. This possibility of life has spurred SETI to perform research on top candidates for extraterrestrial intelligence. Climate and habitability. The average distance from Kepler-22b to its host star Kepler-22 is about 15% less than the distance from Earth to the Sun, but the luminosity of Kepler-22 is about 25% less than that of the Sun. This combination of a shorter average distance from the star and a lower stellar luminosity are consistent with a moderate surface temperature at that distance if it is assumed that the surface is not subject to extreme greenhouse heating. If Kepler-22b is found to move in a highly elliptical orbit, its surface temperature will vary from a higher temperature when close to Kepler-22 to lower when farther away. If the orbit is indeed highly elliptical, then the temperature variance will be extreme. Scientists can estimate the possible surface conditions as follows. In the absence of an atmosphere, its equilibrium temperature would be approximately 11 degrees Celsius. If the atmosphere provides a greenhouse effect similar in magnitude to the one on Earth, it would have an average surface temperature of 22 degrees Celsius. If the atmosphere has a greenhouse effect similar in magnitude to the one on Venus, it would have an average surface temperature of 460 degrees Celsius. Recent estimates suggest Kepler-22b has over 95% probability of being located in the empirical habitable zone defined by the recent Venus and early Mars limits, but less than a 5% chance of being located in the conservative habitable zone estimated from a 1D cloud-free radiative convective model. Limits on satellites. The hunt for exomoons with Kepler project has studied the Kepler photometry of this planet for evidence of transit timing and duration variations that may be caused by an orbiting satellite. Such variations were not found, ruling out the existence of satellites of Kepler-22b above 0.5 for Earth masses at 95% confidence. See also: Earth analog, Gliese 163c, Gliese 581d, Gliese 581g, Gliese 667cc, habitable zone, HD 85512b, Kepler 69c, Kepler 186f, Penthouse 2b, planetary habitability, references. External links: NASA's Kepler confirms its first planet in habitable zone, Kepler discoveries, Kepler-22b, a yearly orbit of 289 days, view of Kepler-22b sky location, Kepler-22b a first discovered planet in habitable zone on YouTube, Kepler-22b a planet in a star's habitable zone on YouTube, Kepler mission newsfeed.